Okay, hi everybody. We were still waiting for people to enter, but I think we can start. So welcome to this webinar. Today we are going to explore the Podium system, which is our new updated real-time analysis system, which is called Podium exactly. And we will analyze in detail a specific sport gesture, the squat jump protocol. Going through the goal of this functional protocol, the test execution, and the interpretation of the report. I'm going to start explaining how the Podium is constituted, and also my colleague, engineer Eleonora Puce, will also help me and start the second part of this training. So first, let's go through an overview of what is meant to be doing sport analysis, sport gesture analysis with BTS systems. What is included in our system, specifically in Podium system, the system highlights, of course, and then we go through all the examples of the applications, and finally, more in detail, how the squat jump protocol is performed. So from the calibration acquisition to the processing until the report explanation. So it will be very complete. So first of all, regarding the overview, I will just remove this. So BTS Sport Analysis provides medical sports personnel with the complete objective information to assess the musculoskeletal situation and the strategies of the athlete during the exercise. It allows the planning of customized training programs based on in-depth knowledge of the actual potential and condition of each individual athlete, avoiding, of course, any risk of overtraining and improving also their performance. Thanks to this objective information, objective analysis, the sport medical staff can plan customized training programs with the aim of enhancing sport performance, identifying any possible weakness in athlete preparation, and of course, reduce the sport injuries. What is included in this specific package? So Podium is a cutting-edge tool that enables comprehensive assessment of an athlete's symmetry and strength of both static and dynamic condition within just a few minutes. By using Podium, coaches and trainers can significantly enhance training regimens, prevent potential injuries, and expedite the recovery process, helping athletes return to their peak condition more swiftly. But what is Podium exactly? Podium is a system constituted of two P6000 triaxial force plates and two PTZ HD color cameras. The force plates measure the three components of the ground reaction forces, the coordinates of the center of pressure and the torque. The PTZ cameras, which are HD color cameras, provide real-time images with the superimposed force vectors and joint angles. So more in particular, P6000 are high performance triaxial force platforms that can be combined also to form a sensorized floor, which is called Infinity. In this case, the normal system, just the standard system consists of two of these force plates. The force plate has been designed for gait, running, impact analysis, any type of clinical and sport gestures. The particular architecture allows to measure the components of the ground reaction forces in all the available length of the sensorized surface without any discontinuity. So, for example, if you touch the ground with your foot in between one and another force plates, you still have very accurate data. The platform is completely digital. The connection is made with Ethernet cable. This is, of course, the guarantees of greater data accuracy compared to normal analog platforms. The PTZ cameras, PTZ webcams are HD colored webcam that allow for superimposed force vector biofeedback during the movement. So when you stand on the force plates, you will see the left and right in superimposed vectors that allows to show in biofeedbacks and to show in real time the loading, the distribution, of course, of the load during movement or also during static analysis. And the possibility also to have joint angles body tracking in real time. In particular, the examination of real-time joint angles that, of course, optimizes sport performance and provides detailed insight of movement biomechanics. These features is still in progress, is still in development. So it's something that we do have, and it's something that we are also working on to be optimized as much as possible. In terms of system highlights of this new version of Podium, one of the standout features of Podium is the integration of synchronized cameras. Usually are two cameras, one on the frontal and one on the sagittal plane of the system of the body of the subject. This advanced setup enables the visualization of force vectors, joint angles superimposed on the athlete also in real time. Such detailed biofeedback of force vectors and joint angles allow athletes and coaches to observe how performance metrics vary with changes in posture, in power, in movement, and the examination of real-time joint angles also optimizes sport performance and provides detailed insights into movement biomechanics. So this very accurate system, of course, is comprehensive of new algorithms, new and updated validated protocols, and also, of course, the possibility to have a very easy to read reports that we will show you right away. It is a fast, accurate analysis. So you ask your athlete, your patient, your subject to just stand on the force plates, and you will see in real time right away the 3D force vectors, the biofeedback. You right away have the possibility to acquire the movement, any movement that you want, of course, and then you have some specific protocols that are related to specific movements that you can just run right away through our processing phase and tracking processing phase, etc. It allows, this is the picture of our software, the capture. It allows to assess forces applied in both static and dynamic scenarios, such as, for example, during posture analysis or squat jumps, counter movement jumps, other type of jumps that we will also show you later. It is an advanced technology because Podium simultaneously shows the three components of forces: vertical, anterior, posterior, and lateral forces, and additional tools such as extra video cameras, electromyographies, and other tools that you can also add on if you need, or if you want to also increase the accuracy and the snapshot of the athlete or the subject that in front of you can be added, as you see also in the screensaver in the screenshot here. One system for multiple purposes, because Podium features biofeedback system that enables user to monitor the body balance and as if they were viewing themselves in the mirror with augmented reality. So in this case, you can both use this system for evaluating, for assessing, but also for training, for working also in real time with the athletes in front of you. And this tool offers, of course, guidance on proper posture or movement, making it an effective self-training system. And finally, the 3D kinematic movement analysis. So the software, of course, allows for precise movement analysis, identification of body segments, enabling detailed biomechanical studies. It can capture and process its data in real time, providing valuable insights for optimizing performance and preventing injuries. Now we will go more deeply into the example of application. So the functions, the motor function that we have decided to develop in order to have like more specific and precise information about parameters. And I will just leave my stage to Eleonora that will continue to the second part of the presentation.
Hi, everyone. So yeah, as Marta mentioned, we'll go deeper in the description of the system by giving some application examples. So the system allows motor function assessment concerning many movements. So in the next slides, we'll go through them. So let's start with the analysis of jumps. In case of jump analysis, the system allows to analyze the athlete performance by means of force, power, and velocity, and also displacement. It allows to obtain many indexes and parameters that also allow a complete evaluation of the athlete performance, such as the rate of force development, rate of power development, the stiffness, drop of velocities, and so on. And many types of jumps can be evaluated. So we have counter movement jump, squat jump, drop jumps, hop test, such for example, repeated counter movement jumps and stiffness jump, so repeated vertical hops. Then the system also allows a postural assessment and a walk analysis. So postural assessment represents a tool for prevention and also allows to get an objective evaluation of the subject's condition in a static position. All these protocols aim to help both clinicians but also sport experts to provide intuitive reports and help also visualizing the progress of the rehabilitation over time. In terms of protocols, the software provides walk in place, gait, and postural stability. Lastly, the system can also be used to monitor the recovery process and to optimize the return to competitive sport activity. These protocols are, for example, a repeated squat to check the athlete resistance, symmetry, and stability during the movement, change of direction to test the reactivity and also the movement coordination. And it is, of course, useful to monitor the athlete's return to play. The IMPT test, which is the isometric mid-tight pull, which is a useful tool to test the maximal strength and to evaluate the isometric force development. In fact, it has been shown to correlate with vertical jumps and sprints. Research has found a correlation between maximum strength and sprint speed, and also between the rate of force development and vertical jump performance. And finally, in case it's needed, we can also create protocols upon request, to analyze specific motor gesture performed in specific sports, like, for example, the swing in golf, just to give you an example. Okay, so we wanted to give you a practical example of what we can do with the system. So we are going to provide a detailed analysis of a squat jump using of course the squat jump protocol, and using some videos we'll go through all the steps needed to calibrate the system, to perform an acquisition, to post-process the data and get the report. And together we'll also discuss the obtained results facing the main parameters that can be useful to assess the athlete performance. So here's a video showing the calibration, which is quick and easy. The calibration routine is a series of action and commands that must be executed to align and synchronize the camera and the platform. It allows to measure the distances, the angles, the orientation of the cameras, and to generate a coordinated system.
Upon entering your Smart Clinic or Smart Performance software, start calibrating the system, clicking on the calibration button. To calibrate Podium, use two tools and follow a set of step-by-step instructions. The first thing to do is to calibrate each PTZ color camera. Wield the chessboard calibration tool with both hands so that the checkerboard faces outward. Stand in front of the camera PTZ camera to be calibrated at a distance of about 1.5 meters. Once the acquisition has started, move the tool trying to cover the entire camera frame by making the following movements. Shifts up and down, left and right, small rotations in the sagittal plane, and small shifts forward and backward. After 50% progress, rotate the tool 90 degrees. And repeat the operation from the previous step. After PTZ camera's calibration, use the QR code tool to calibrate the force pleats based on the position of the PTZs. Place the QR code on plate 1 and match the red corner with vertex 1 of the plate. After verifying that all PTZs frame the calibration tool correctly, the calibration is complete and you can start the acquisition. At the end of the process, the system will be ready for motion acquisition.
Okay, now after the calibration of the system, we have to actually acquire the trial. So there's a video showing how to acquire and record the trial.
From the software interface, let's create the patient profile by clicking on New Patient and fill in all the mandatory fields. That is name, surname, birthday, and gender. Then click on Add Patient. Then create a session by clicking on New Session, type the session name, and create the pathology if needed. Select the protocol that you want to use for the acquisition. In this case, jump analysis 2 ground reaction forces. Insert anthropometric measurements. Then click on Create Session. Click on New Trial. Select the type of test to acquire and start the acquisition. Select the devices needed to acquire the trial, in this case force plates and video. Click on Monitor and ask the athlete to go to the podium. The subject must be positioned on the platforms in front of the camera that makes the frontal plane framing. The subject's arms at sides, 1 foot on each platform or group of platform, and with the heels aligned. Once the subject has risen on the force plates and is standing still in an orthostatic position, it is possible to begin the acquisition of the test. The orthostatic rest position must be maintained for at least 3 seconds. Then the athlete must reach the squat position, bending their knees to about 90 degrees, and hold this position for at least 3 seconds. Then jump at maximum intensity, trying to jump vertically as high as possible. From the squat position, it is important to avoid any counter movement before jumping. Landing must be performed with the feet touching the corresponding force platform at the same time. Acquisitions must be stopped at least 2 to 3 seconds after the jump has ended. The athlete must not get off the platforms until the end of the acquisition. When the subject is ready, click on Acquisition to start the acquisition. At the end of the trial, click again on the Acquisition button to stop the trial, and then save it. You can add notes if necessary.
Okay, perfect. So after the recording, of course, it's important it's important to process the data. So in this video, we'll see the tracking, the processing, and the creation of the report.
Once the trial is acquired and saved, it needs to be tracked and processed. Select the session containing the acquired trial and double-click on the trial to automatically move it in the Trials to be Tracked window. Tracking of 3D force vectors displayed on the platforms and superimposed on the video must be carried out. This means that they must be associated with appropriate and corresponding labels, right and left ground reaction force. The label must be chosen based on the foot that rests on each platform. If the assignment was made within the Evo capture, this step is unnecessary. Once done, click on Save and OK. After tracking, the trial will automatically be transferred to the window called Trials to be Processed. Select the squat jump processing protocol to calculate the force data related to the squat jump test performed. The identification of the events is automatically performed by the protocol. The user only has to identify the jump stop, the jump start, and the start of the propulsive phase. Finally, the trial is now in the last window and ready to be transferred to the final report. For a complete analysis of jump using ground reaction force analysis, one report needs to be processed and created. Open the report model for squat jump. Immediately, the software shows the report preview where you find one page with all the information for each movement performed. By clicking on the printer button, it's possible to print the report or save it in PDF format by using the virtual printer.
Okay, perfect.
Once the trial is acquired,
Lastly, we will go through the report. So we'll analyze the parameters obtained in the report.
the squat jump report is dedicated to force analysis and is divided into 6 pages. The first page presents the subject's personal and anthropometric data. The second page analyzes the squat jump phases. The graphs on the left display displacement, velocity, vertical force, and power profiles during a single jump cycle. Each movement phase is highlighted with a different colored background, as indicated by the legend at the bottom of the page. The right side of the page contains temporal parameters, including jump time, time to peak force, time to impact, and time to stabilization. Jump time is the total duration of the jump. Time to peak force is the time from the start to the peak force in the pre-jump phase. Time to impact is the time from landing to the peak force during the landing phase. Time to stabilization is the time from landing until the force stabilizes at body weight, when the force returns to the body weight value. The duration of each jump phase is also provided in milliseconds and as a percentage of the total jump time. The third page focuses on key parameters related to displacement, velocity, and vertical force. Displacement parameters are presented in the top section. Squat depth is the downward displacement of the center of mass from the standing position to the squat position. Flight height is the jump height calculated using the time of flight formula measured from the takeoff moment. Max height is an alternative jump height measurement calculated from the standing position reached during the propulsive phase instead of the takeoff moment. Velocity parameters are presented in the middle section. Velocity at toe-off is the velocity achieved at the exact toe-off moment. Drop-off velocity is the difference between the peak propulsive velocity and the velocity at toe-off. This metric provides insight into the athlete's performance as it reflects speed loss at takeoff. High coordination and a well-executed jump are indicated when peak velocity matches toe-off velocity. A discrepancy suggests a loss of efficiency. Vertical force parameters, presented in the bottom section, is the mean and peak forces during different jump phases. Rate of force development is the ratio of force to the duration of a jump phase. It represents explosive force development and reflects how quickly force increases. A steeper force profile indicates higher RFD, which is associated with better coordination and efficiency. Net impulse is defined as the force produced in a jump phase multiplied by the duration of that phase. Graphically, it is the area enclosed between the weight line and the force profile. This indicates the subject's capacity to produce and store force. Stiffness is evaluated during the landing phase as the ratio of peak force to the downward displacement of the center of mass. Stiffness depends on muscle fiber stretch and tissue elasticity. Higher stiffness implies less leg flexion during force absorption. Impact ratio is the ratio of maximum landing force to maximum propulsive force. Ideally, this value should be 1. A high impact ratio indicates excessive landing forces, increasing the risk of injury. If landing force doubles takeoff force, impact ratio equal to 2, injury risk is significant. Overloads during landing should be minimized. When analyzing these indexes, we suggest to consider both impact ratio and stiffness together in order to have a more precise view of the athlete's movement at landing. The fourth page focuses on symmetry and load distribution. It evaluates the percentage distribution of mean and peak forces and RFD between the left and right sides during the propulsive and landing phases. The last two tables present peak forces for the anteroposterior and mediolateral components during the propulsive and landing phases for both the left and right limbs. This provides an overview of symmetry and global coordination during the movement. Quantifying asymmetry is essential for preventing structural overloads that can cause pain and impair performance. Additionally, analyzing the anteroposterior component can measure force dispersion. During the pre-jump phase, minimizing the anteroposterior component ensures maximal vertical thrust for optimal jump height. The fifth page analyzes power values and the center of pressure before and after the jump. The first table evaluates the overall power developed during the propulsive phase, including mean and peak values, and the rate of power development. Power is calculated as the product of vertical force and velocity, normalized to body weight. The second table assesses symmetry in power development during the propulsive phase, showing each side's percentage contribution to total power. Center of pressure analysis in the bottom section displays the center of pressure position for each side at toe-off and landing. Anterior-posterior and mediolateral shifts are also reported, allowing an assessment of symmetry and coordination during the jump. The final page provides values for the vertical, anteroposterior, and mediolateral force components for both the left and right sides at the start, peak of the propulsive phase, and peak of the landing phase. Additionally, for a qualitative assessment, there are two images, frontal and sagittal views, of the athlete during each jump phase, with corresponding superimposed force vectors.
Okay, so this was an overview of the report. We show what we think are the main parameters, but if you have any question, any doubt, we were not clear at any point, please let us know and you can ask a question.
Yeah, we understand that are a lot of parameters, and we put everything in just one big video. But also if you want, you can also this webinar will be also available online, so you can also check in them later and see if you have any other questions. You can always reach out. Here, someone is asking first if clients or people already have force platforms in the analysis lab, in their own gate lab or sport lab, also BTS. It is possible, of course, to have our own new updated protocols. You just need to ask your sales manager of reference of the of course, market area of interest, and we will send you the possibility, of course, to just download all our protocols, and just if you want also to do upgrades.
Someone's also asking, did you evaluate the accuracy of your algorithm for data analysis? So the algorithm, of course, and all the indexes that are present in the report are taken by literature, and also the calculation are based on papers and studies. And if you're interested, we can send, of course, the paper and literature.
Yeah, we have a list of references, and of course, our data are based on the gold standard. So, if you have any other questions or curiosities or doubts regarding our systems or anything else, we are here. I also want to remind you that this is just an example of jump protocol. We used the squat jump because it's also very used also in sport literature, but we have different other types, as also Eleonora was saying before. jump is, with also different specific reports and other parameters that can be extracted. All the reports and the protocols can be also personalized. They are customizable upon request. Of course, you can reach us and talk to our technicians, and of course, we are very willing to help you to improve and implement your own sport analysis. Another thing that I wanted to add is the possibility to join us at the next Arabelth that will be next January, so 2025 in January. And our system, also podium system, will be there, so you will also have the possibility to try it and to ask our representative there to show you the protocols and the results, and some results. Is there any opportunity for individuals to try this out in London? If you buy it in London, of course. We can ask our distributors there to reach you as soon as possible, of course, with more information in Great Britain or UK area. So we will definitely send you, like, if it's possible, your contact to our distributors there. And yes, you can, of course, try and see more in detail how reports are performed, protocols are performed. You can also, if you want, set a demo, a demonstration also live from here, so you can also reach out also from Italy.
It is possible to measure the displacement of the center of mass during the standing position on plates. Yes, we maybe not during the, not using the jumps, but we have the static protocol that does exactly this. So measure the movement of the center of mass and also the distribution of forces while standing still. So yes.
It is possible to evaluate other movements. Yes, it is. It is possible to evaluate. We just gave you an example of jump, which can be from squat to counter movement to any other type of jumps. But of course, yes, you can also ask, you can also create your own specific protocols if you want. If you are also an expert in signal processing, for example, you can integrate, use our systems to acquire your own data, then create your specific protocols, from golfing to baseball to any other type of movement. So we helped clients that were analyzing cricket like a few months ago with these specific protocols regarding this type of gestures. So of course you can also work a lot on specific movements, both for sports and medical clinical field. I think, it's pretty quiet here, so we will of course save this webinar and keep and put it online on our website. So if you want, you can come back anytime and download it and see also our videos that are very specific on this sport gesture. And I think that's it.
Yeah, if you have other questions, you can reach us by email.
Yeah. Thank you for attending, and thank you very much for your time. See you next month. Next month we will have another webinar that will be more specific about nirvana and neurorehabilitation. Wait. Thank you. Thank you for saying thank you, and bye. Thanks.
Bye-bye.